We have two special triangles that we want to identify in trigonometry, and the first one that we're going to focus in this video are going to be a 30, 60, 90 triangle. And so let's talk about that for just a minute. A 30, 60, 90 right triangle comes from a basic equilateral triangle. And if we were to let an equilateral triangle which has angles, all three of its angles are the same, that's why it's equilateral, or equiangular in this particular case. All three of these angles have to be the same, so that makes them 60 degrees each. And if we have an equilateral triangle, then each of the three sides would also have to be the same. So we're going to let this triangle have sides that are equal to 2. Now if I were to drop a line perpendicular down from the vertex to the side opposite, so if I were to drop a line perpendicular down to the side opposite, I then have created two separate right triangles, which is what you see over here in this image. Because I now have a right angle down here in the bottom, and because I have 60 degrees over here in the leftmost position, I have 30 degrees up here in the top, also because I divided it directly in half, which was the whole idea. So what I created now is one triangle that is of size 30, 60, and 90. That has angles of 30, 60, and 90. Well, the idea here is, since I created this, these two equal triangles on both halves, then I have split this base side in half as well. So it's no longer a distance of 2. Instead, I have divided that up equally among the two triangles, so now my base leg is of distance 1. So I have a short leg of size 1. I have a hypotenuse over here that didn't change, and it is of size 2. And I have some value represented by this other remaining leg right here. We can use Pythagorean's theorem to figure out what that height is, if you don't remember what that height was already. And we can do that by taking 1 squared plus the x squared leg must be equal to 2 squared, because the square of one leg plus the square of another leg has to be equal to the square of the hypotenuse. And we can solve for the variable x. So I'm going to say x squared is going to be equal to 4 minus 1, which would be 3. And then when I take the square root of both sides, I find out that x has to be the square root of 3. So in a 30, 60, 90 triangle with sides of ratio 1, 2, 1 for a leg, 2 for a hypotenuse, the remaining leg has to be the square root of 3. And this is a classic triangle that you need to memorize. Now the way that I always remember where the 1, the 2, and the square root of 3 are located on my triangle has to do with the idea that the smallest leg, and that's usually the one I start with, the smallest leg is always across from the smallest angle. So the 1 out of this pairing, because I remember 1, 2, and the square root of 3, the 1 has to fall across from the smallest angle, and the 2, the number 2, which is in fact greater than the square root of 3, the number 2 then has to fall across from the largest angle. So the largest side is always across from the largest angle, the smallest side is across from the smallest angle, and then by process of elimination that would tell me then that this remaining leg has to be where the square root of 3 goes. So this is a special triangle that we're going to be utilizing quite a bit through the remainder of our trigonometry, but let's see if we can come up with then, based on that triangle, we want to find the 6 trig function values for a 30-degree angle. We already know how to find those function values based on right triangle trigonometry, which was SOHCAHTOA. So I'm just going to come over here and I'm going to highlight that we're talking about the 30-degree angle that I want to know the function values of. So if I wanted to know what the sine of 30 degrees is, that's going to be opposite over hypotenuse, or 1 over 2. The cosine then of 30 degrees is going to be adjacent over hypotenuse, or in other words, the square root of 3 over 2. And tangent of 30 degrees is going to be opposite over adjacent, which would be 1 over the square root of 3. Now we can't leave the radical in the denominator, so I'm going to multiply top and bottom by the square root of 3, and that gives me the square root of 3 over 3. So let's move on and find the 3 remaining function values by simply taking the reciprocal identities here. So the cosecant of 30 degrees is going to be 2 over 1, or just 2. The secant of 30 degrees is going to be 2 over the square root of 3, or 2 square roots of 3 over 3 once I rationalize that denominator. And then cotangent of 30 degrees is going to be the square root of 3 over 1, or just the square root of 3. So these are the 6 trig function values for 30 degrees, and then I could also go in and do a similar process if I wanted to figure out what the function values were for 60 degrees. Now let's go ahead and continue our discussion here, talking about the remaining special triangle, and that's a 45, 45, 90 triangle. So unlike a 30, 60, 90, this is the other triangle that we want to focus on. And if we're looking at a 45, 45, 90 triangle, the sides and hypotenuse on a 45, 45, 90 have 2 sides that are exactly the same, and the hypotenuse of that is going to be the square root of 2. And I leave it up to you to derive that hypotenuse if you'd like, but it's just simply done using Pythagorean's theorem. So if I have a 45, 45 special triangle, and I want to know what those 6 trig function values are for a 45-degree angle, we can pick either of the 2 45-degree angles in here to look at. And let's go ahead and look at this one down here in the bottom. So when I find the sine of 45, the sine of 45 degrees is going to be opposite over hypotenuse. The side opposite is 1, the hypotenuse is the square root of 2, so this is going to be the square root of 2 over 2 when I rationalize the denominator. The cosine of 45, the cosine of 45 is going to be adjacent over hypotenuse, which again is 1 over the square root of 2. So once again, the square root of 2 over 2. Tangent of 45 degrees would be opposite over adjacent. That would be 1 over 1, or just 1. So this goes pretty fast once we kind of have sides of our triangle and we're filling it in. So I've got the cosecant of 45, which is going to be the square root of 2 over 1, or just the square root of 2. Secant of 45 is going to be the same value, just the square root of 2, and cotangent of 45 is going to just be 1. So we have these special triangles here. We have a 30, 60, 90 triangle, and then we also have a 45, 45 triangle, and they are so special and so important to us for the remainder of our trig that it is important for us to start memorizing these function values for these 3 special angles. In other words, you need to start memorizing now what sine, cosine, tangent, cotangent, secant, and cosecant are for these 3 special angles that we have talked about.